For the problem 5, we know that there are exactly K customer arrives within time t minutes follows the Poisson process. And from the questions, we know that when t is greater, 1t is equal to 2 and k is greater than 1, the probability is 0.3. So we have t equals to 2 and k greater than 1 equals 0.3, and which is the counterpart of t equal to 2, k smaller than 1. And because k only takes integer, which we can know that t equals to 2, k equals to 0. Then we can derive that in 2 minutes there are no customer arrive. This probability equals to 0.7. So we just write the formula as e the power of minus lambda times 2 times this lambda times 2 to the power of 0 equals to 0.7. And solving this equation, and we can know that lambda equals to 0.1783, and this is for the first part of this problem. And for the second part of these problems, we want to know that the probability that in 3 minutes no customers comes. So here we got that we want to know that t equals to 3 and k equals to 0. We need to calculate this probability. And we just plug in the lambda we got in the previous equation. We e the power of minus lambda times 3 times 3 lambda, the power of 0. And plug in the lambda we got. We get this probability equals to 58.57%. And this is for the part 2. And for the part 3, we want to find the probability that in 10 minutes at least 2 customers will arrive. So we need to find t equals to 10 and k greater than 2, which is the counterpart of t equals to 10, k smaller than 2. As k only takes integers from 0, so we know this equals to 1 minus the probability of in 10 minutes only one customer arrive minus the probability that in 10 minutes no customers will arrive. And we need to plug in the lambda we just got in the previous part, and we calculate this probability, which is equal to 1 minus 1 minus this one, 10 times lambda power of 1 minus e the power of minus lambda times 10 times 0, 10 lambda 0, the power of 0. And we got this percentage as 53.21%. And this is for the part 3. And for the part 2, we need to find the probability that in 1 minute exactly one customer will arrive. So for the part 4, it is just the case that t equals to 1 and k equals to 1, and we just need to plug in the value of t and k into the Poisson formula, and we get the answer is 15.92%. And for this problem, we need to notice that the number of customers arrive in the time range of 0 to t follows the Poisson process. And we also need to outline the counterpart of the probability, which is the whole probability equals to 1. And by applying these two insights, we can solve this problem.